All right, good afternoon. My name is Julie. I work at Google. I'm up in the Seattle office, and I'm the author of Protractor. And as soon as we get the presentation back up.
Hi, I'm Chirayu, and I work at the Mountain View office with the Angular team. I did some security work for AngularJS, and I'm working on Angular Dart.
Cool. So we're going to be talking. We're going to be talking about testing, specifically end-to-end testing, and what Protractor is doing and what the Testability API in Angular is. So first of all, let's give a quick overview of what our goals are and what we're doing with end-to-end testing. So from my perspective, the goal of testing in general is to increase your confidence in your code so that you can release it or push it to the next step. If you're not Brian Ford, who never writes bugs, you probably write a lot of bugs. I think I write 2 bugs per line of code. And so we need tests to help us catch these as soon as possible. Unit tests are designed to be contained tests for maybe one file, one service or controller or method. And in unit tests, you'll usually be mocking out any external dependencies that are expensive that you're working with. And you're probably familiar with writing these and the great setup that Angular has with tools like Karma and built-in things like ngMocks. So what's end-to-end testing? So end-to-end testing is for when you want to test that all of your components actually work together. It's often called integration testing or functional testing. I don't really distinguish between these terms. It just means some way of testing more that your whole app actually works. So this is often thought of as if you could replace someone manually going through and clicking things in your application. Would that work out?
4 fingers, 5 to the left. Okay.
Excellent. So you can think of this as, from a user perspective, running on a real browser, does your application load? Does it work in different browsers? Does it connect to your backend, maybe your data storage? Do all of those pieces fit together? So Chirayu, you've been at Google for a while. What's your experience with end-to-end testing been?
So a few years ago at YouTube, when we were writing the first set of end-to-end tests ever, my experience with end-to-end testing was that it had to really be much better. The experience wasn't great. There were all these magic timeouts. The tests ran really slowly. They were flaky. So Selenium testing meant that I wasn't very excited about it, which also hurt adoption because not as many developers were adding new tests, and they were going stale, and we would only discover those on production day.
Yeah, so end-to-end testing has a, I think, earned reputation for kind of being a pain and being hard to debug and flaky. And our goal is to eliminate that and make end-to-end testing surprisingly painless for Angular applications. So I want to start with this example. A little while ago, we were migrating Angular's tests over to use Protractor from the old scenario runner, which you may remember from back in the day. And we came around this one, which was trying to input a URL into this little model box here. And the test was failing. And every time we got to the slashes, it would stop typing. And we looked and people said, what's wrong with Protractor, Julie? We're moving stuff over. And actually, it turned out that what was happening is that the search bar was stealing focus whenever you typed a slash. So it would never complete the URL. And we fixed this. And I love this example because it requires that you're actually sending input like a user would be typing, not just setting the value of this input box. And it requires that all of the components be on the page so that the search box is there in context with the actual piece of documentation that we're testing. And so this shows the type of things that end-to-end testing will catch that you wouldn't get in unit tests. So as I mentioned, Protractor is our tool for end-to-end testing. And we had our official 1.0 release just in July, which means that we think the API is pretty stable and ready to use. And we've been working on it since then.
Julie. Do we have any documentation to go with that?
We do have documentation to go with that. So as Pete mentioned, we're using Jenny, and all the docs are up at protractortest.org. And we rewrote them as well as making a pretty website. So there's a brand new tutorial and much improved documentation from a little bit before 1.0. So if you haven't seen it in a while or you're just getting started with Protractor, I'd encourage you to go take a look at that.
How does Protractor work?
All right, so the basic idea here, Protractor is a node module. So you can download it with npm install Protractor. And the idea is that it's built on top of a tool called WebDriver. WebDriver is a standard for having a test process that talks to real browsers and emulates user actions using something that'll drive the browser on those real browsers. And the communication here is over something called the WebDriver protocol. This protocol gives us methods for finding elements, changing the URL, interacting with elements, clicking on them and sending text to them, and then getting information back in the form of what's displayed or what attributes are available. So Protractor is implemented in Node.js so that you're writing your tests in JavaScript, which is probably the language that you're spending most of your time coding in, and talks over the WebDriver protocol to all of this stuff on the browser. It takes in two input sets. First is a configuration file, and then the actual tests themselves. If you've used Karma, this separation of the config stuff from the actual test logic is probably pretty familiar to you. It lets you use a different configuration to run the same tests and helps keep things clean. So you get those in, and you launch a test run.
What goes inside one of those config files?
Good question. So this is the start of the configuration file. You have to tell Protractor, first of all, how it's going to go and drive those browsers. So there's a little bit of setup that we have a couple of utilities to make easier, and this is all listed in the tutorial. But the most common way is to have a Selenium server that's running locally and then just point to the address that that's running at, which is what this setup shows. However, you could do a lot of different things. So there's this great tool called Sauce Labs that we have pretty tight integration with, and this is how we run our own tests, which gives you browser VMs with different versions on different operating systems. And so you can chart out to a whole bunch of different sets and make sure that your application works on all sorts of different setups. And then the second thing is, what browsers do you actually want to use? And this is specified in something called this capabilities object. This is the simplest type, which just gives a browser name. So say, here we're running our tests on Internet Explorer.
If I want to test more than one browser at the same time?
You can do that. So recently, we introduced a multi-capabilities object, which lets you run your tests in parallel on several different browsers at once. You could also do things like shard your tests among browsers so that you're running one test file on the same browser in parallel to make everything go faster. And there's a whole bunch more options that I don't have time to talk about right now, but they're all in the reference config file, which is in our docs at referenceconf.js. OK, so let's take a look at the actual test body. So to keep tests for end-to-end easy and familiar, we try to borrow as much from unit testing as possible. So the Jasmine syntax is the primary syntax that we develop for on Protractor, although you can switch to others if you are more comfortable with that. But for Jasmine, we've got these describe blocks before each and it, and then expectations, which work just like they would in unit tests, with a little bit of patching to make async work behind the scenes. So that's the scaffolding. And then in the actual body of the test, you'll be doing things using some globals that Protractor exports to interact with your web page. And the most important of these, and the one I'm going to focus on today, is this global element function, which takes some method of locating an element and returns something that we like to call an element finder, which is a powerful object for interacting with that. So say you had a web page like this. I've learned from material design that we don't do curved corners anymore, so this is my material design homage. And so we've got an Angular app with an input and something that's bound via interpolation to something called greeting. So you could find these elements by using these special selectors that Protractor gives you, which are by model and by binding. And then you just put in the name as expected. Now to actually do something with these elements, we call some action functions. So this first one would clear out anything that's already in the input, and then you can chain that with another action, like typing in some keys, typing ABC to this input. You can also get information back from the element by getting text from it, and there's also methods for finding attributes. If you need to be more specific about how to find elements, you can use things like by CSS or by ID for CSS selectors, as you are familiar with, or just using the ID of an element. And in this case, we're actually chaining element calls to find sub-elements. So here there's two input boxes with the same ng model, but they're in different divs. So we scope the search at first to that first div, and then that'll only find the correct input. I'm going to say OK. I didn't read that. You can also deal with multiple elements at once using the element.all function, which has powerful methods that let you do filtering or mapping and reducing over an array of elements. And then you can actually perform actions that'll sequentially work on multiple elements. So if, for example, here, if this filter function didn't actually filter anything out, this would click on all of those LIs sequentially.
Wow. So the element function does a whole bunch of stuff. How does it do its magic?
So behind the scenes, what this is doing is queuing up a bunch of asynchronous actions. So everything that we actually do has to go over that WebDriver wire protocol and do something on the browser and wait for a response. So this is all asynchronous and all working in promises behind the scenes. But Protractor has this command queue, which we call the control flow. And what actually happens with this bit of code is that we'll queue up a bunch of actions. The first one is really important, which is a wait action. And we'll talk about how this works a little bit more. But this is aware of how Angular works, and so it hooks in and waits until any processing or HTTP requests are done so that you won't get race conditions in your tests, and you won't get flaky tests, which is a huge issue for end-to-end tests in general. And then we queue up the other calls, which are finding that element and then clearing it and sending keys. And then once your test is ready to run, these will all go one at a time for the control flow, and you'll get your output. As I said, these are all promises behind the scenes, so you could write this using then functions, but Protractor manages this for you, so you don't have to. And it's also worth noting that the expectation framework in Jasmine, so if you expect the text of some element to be something, will also automatically wait for that for you, so you can use that like it's synchronous and not worry about dealing with the promises. Before we move on, I want to just quickly talk about a couple of best practices that we've thought of for writing end-to-end tests. And the first, I think, is actually useful for all tests, which is to limit logic inside your test. This is good for a couple of reasons. It makes it a lot easier to read for yourself in the future or other devs who might be looking at it. It makes sure that you're not duplicating your production code in your test again, which means you're really not testing anything. And it makes sure you're not accidentally missing conditions because you're misreading your test and you thought that your for loop was covering something that it didn't. And this will make your test a lot easier to read and makes Protractor tests a lot simpler. All right, so this one's much more specific to Protractor. There's a pattern called page objects, which you may have heard of. And all this really means is that if you're going to be reusing elements in different tests, say you have a navigation menu, and you're using this throughout your application, you can take that, split it into a separate variable, and put it in a different file, and use it in all of your tests. And so the idea is that you've got reusable code which will say how to find your elements and how to do basic things with them. And then you can use that in your tests so that your tests read better, and so that if you ever change this navigation menu, there's one place to go and update it. And the final thing I want to talk about is debugging with a function that we introduced recently called pause. And this is still slightly in beta, but I think it's the best way to debug applications right now. So you introduce this little browser.pause statement anywhere in your tests, and it'll actually stop at the execution. You don't have to change the way you're running your test at all. Just start up a new test run from the command line. It'll pause and let you interact with the browser, or open up the console if you want to, and see what's going on, to try to figure out why your tests are failing or what you should be doing next. If you want some examples, I think examples of tests are the best way to learn. Protractor has its own test suite, which is under our repository in spec-basic. And this has a bunch of examples of all of those functions that the element function will give you, as well as different ways of locating items and how to interact with other aspects of the browser. And Chirayu, where are Angular's end-to-end tests?
That's a good question. So as Pete was talking mentioning in his talk earlier, AngularJS has its great documentation generated by Jenny, and it extracts end-to-end tests that you can use for all of your directives from the source code, and you can see them in the documentation page. If you just wanted to see them in the code, you would go onto the source directory, open up any of the code files, any of the directives, and in the doc comments, if you probably search for just protractor.js, you will see the end-to-end tests for that directive. And those are actually extracted out and run on Travis. So we know that what we're showing you is a working test. For Angular Dart, at the top level of the code base, there's a test_e2e folder. And that contains Protractor tests for testing the example application, which has like a hello world, a repeater, and an animation and stuff like that. And you could just poke around that to see how you could be writing tests for that.
OK, this is pretty cool. So can you tell us a little bit about like what's actually going on from Angular's side to make all this work?
Yeah, sure. So on Angular, Angular exposes in all of its variants, right? AngularJS and Angular Dart, one JavaScript API at the top level, which you can get from the Angular object that way. And so you would just get a hold of this Testability API, and Protractor would use that Testability API to do all of its work.
Cool. So what's the advantage of having one API for all the versions?
So before we had Angular Dart, and Protractor was in its earlier versions, it understood a lot about how AngularJS worked. So it was tied to the specific implementation, which worked great, but it meant that if AngularJS had a breaking change to some of the assumptions that Protractor made, your Protractor test would break and you wouldn't know why, especially if you wanted your same test to work against the next version of Angular and the current version of Angular, which was, you were canarying a version. It also meant that it wasn't going to work against Angular Dart. By having a common testability API, it means that your tests will not be as flaky, and the same tests will work against AngularJS or Angular Dart, or if you wrote your application in some future version of Angular which used something completely different.
Oh, yeah, that sounds great. I don't want my tests to break when I update versions.
Exactly.
So what does this actually look like? What's in this API?
So the API currently is fairly basic. You have the find bindings call and something similar to that called find models. You would use it just like that. On the testability API, you would say, hey, find me all the bindings that contains a user.name. And it does, you can specify if you want a strict match, an exact match. But you would get a list of all the elements that use those bindings. And similarly, you could use find models. And Protractor uses these for its locators, the ones you saw earlier, the by.binding and by.models. And so Angular would be providing Protractor these elements that it discovered on its own, so it doesn't have to know how to get these things. There's also a couple ones for setting and getting the location. And there's one for turning off animations. You would typically, if your application had animations in it, you might want to say testability dot, allow animations of false right in the beginning and turn off animations. What this allows you to do is write your tests so that it's agnostic to whether or not you had animations, so you don't have to account for the animation time. This means your tests are faster, but also it means that you're going to be testing the core functionality of your application and not dealing with what happened if it were animating or not. You can always write tests for animations enabled as well, but the test code will look a little bit different, and you don't want that to be a part of every test that you're writing.
Cool.
Finally, there's one other important API, the when stable API, and this is a way of getting notified when Angular has no pending operations in the background. That would include things like XHRs, HTTP gets, template loads, or even a digest that's in progress. This is important because, as Julie was showing, the expect framework that Protractor is using is allowing you to do this automatic waiting. You don't have these timeouts you had to specify somewhere. So when you say, hey, click this button, and now expect that the text below it that has this binding is going to be this specific value, Protractor can wait the exact amount of time that it takes for that text to get rendered based on whatever asynchronous stuff needs to happen, and wait no more. So it's almost automatic, right? So your tests are still going to be written as if it was synchronous, not worrying about the asynchronous stuff, and the waiting is automatic and hidden from you.
So this all sounds good, but this kind of looks like putting debugging code in the production version of Angular, right? Which is generally something that, I don't know, that feels kind of bad.
Good question. It's a hard one. You take it.
OK. So we thought about this. And I thought, well, why does it kind of knee-jerk reaction feel bad to put debugging code in something in production? And I thought of a couple of reasons. So the first is that it's kind of sloppy developing. And I don't think this is true in our case, because the testability service is nicely encapsulated for the versions of Angular that we have now, and we can keep this going forward. I think there was also questions about maybe that's insecure, which doesn't really apply to something like Angular, which is all client-side, so it's all in the browser. You can see everything and do everything in the JS console anyway. And then there would be concerns about, was this increasing the file size? So we measured increasing the testability API. This is for Angular 1.3, and it's less than a K, so very small addition. And then finally, will it slow down your application? So for most of the testability API, the work isn't actually done until you call the API from within your tests, so it doesn't really matter. However, there is this debug info, which Jeff talked about a little bit in the new features in Angular 1.3 talk. And this does slow things down a little bit. This is adding information about like the ng-binding class and ng-scope class, and Protractor uses this. So you can turn this off with an option on the compile provider. And Protractor will go in and turn it on for just your tests on the same version of the application. So you get the speed increase when you're not running your app as a test, and when Protractors run against it, it'll go in and inject a little module which turns that debug info back on so that it can run its tests as normal. So Chirayu, you've been working with Angular Dart. Can you tell us a little bit about what's going on with the Dart versions of these end-to-end tests?
Sure. So I mentioned earlier that Angular Dart had some end-to-end tests in its test E2E folder. Here's one which is just testing the Hello World example that ships with Angular Dart. And if you look at the code, it looks more or less like the JavaScript example that Julie had showed earlier. That's because it's using the same Jasmine API. And other than the fact that it has a fat arrow and it doesn't use a function keyword, you could almost say it's JavaScript code. It's almost the same thing. To get this to work, you need to do a couple things. One of them is that today you would use a Protractor dev fork, but it's still the same Protractor as the mainline version. It just knows how to handle Dart code. And this will get merged into the mainline in like a month or something, and then you would just use the same Protractor. In addition, to get the Jasmine API, you would depend on the pub package called Protractor, and then you would import Protractor API.dart at the top of your spec file, and that should be it. You would get everything. One additional thing, like in the example I just showed the describe block, but Dart files need to stick code inside a main method. So just stick that describe block inside the main method, and that's it. You would be done. And all this still runs in Node.js, so anything else that you wanted with your regular Protractor that you were doing with Node.js will continue to work.
OK, so it runs in Node.js. So what we're doing is actually taking the Dart code and compiling it to JavaScript to run it on the same version of Protractor. So we rewrote Angular in Dart. Why didn't we rewrite this in Dart? Why is it all still just compiled to JavaScript?
Yeah, that's a good question. So why should you be transpiling from Dart to JavaScript if everything else is just running in the VM? There's a few reasons. And the primary reason is that if you fork the code base, you lose a bunch of the features that Protractor has. So for instance, by keeping a single code base, Julie mentioned earlier you had multi-capabilities, and you could add a count parameters to say, I want to shard my test n ways, and then it's going to run n times faster in theory. That you would just get for free, because any changes that go into the Protractor code base would also apply to your Dart code. And that works for things like extra browser support if you want to run on Sauce Labs. If you have the element function, which grows new capabilities, new chaining things, you would get all of that for free on all future bug fixes and features and things like that.
Cool. So as I mentioned, we released 1.0 in July, but we're still definitely working on Protractor. And we have a bunch of things coming up. The first being debugging improvements, since debugging end-to-end tests is historically a pain and still not nearly as easy as I would like, even with the improvements that Protractor already gives you. We also want to give some sort of insight into why maybe tests are being slow. So some high-level latency profiling, not low-level benchmarking of DOM manipulation, but just where's the bulk of time in my test being spent. There's a new project called Sync Driver, which is going to be open sourced soon, that is a smarter way to figure out when to synchronize with your application. So when we need to do that when stable call to make sure that no race conditions get introduced. So we're looking into easy ways to use that. And finally, documentation updates, a more advanced tutorial, and some collections of best practices for end-to-end tests. All right, thanks, everybody. We will be available to answer questions. We've just kind of scratched the surface here, and we hope you give Protractor a try.
Wait.